Hello everyone, welcome to a new tutorial presented by the SHLDB. In this tutorial, we are going to learn how to calculate the median using C programming. Now, a simple example with the median, the first thing to note is that what's the median? The median is the middle value of the variables in an ordered series. So definition of the median, we say median is the middle value of the variable in an ordered series. So this is the median. The median is middle variable of the middle value of the variable in an ordered series. So middle value is very important and ordered series is very important. Now let's come in this question. Age, let's say you have ages of 8 people and you have 12 years, 13 years and all that. Just coming to find the middle value here will not give you the median. So when you want to have the median, you must consider these two statements, middle value and ordered series. So you first need to order this statement in ascending order. So you have the first one will be 9, then 9, it will be 8, then 9, then 9, then 12, then 12, then 12, then 12, then 13 and 13. So this is the order you're supposed to have in order for you to find the middle value, which is the median. So you need first to order and then you have to find the middle value. So you have to tell now the computer, the first thing you have to tell the computer is how to order these values which are being entered. And the second thing to tell to a computer is how to choose the middle value when it has been ordered. So before that, I'm going to ask to the user to enter the total number of terms he wants, the total number of terms of his variables. So in order to ask that, I'll use the function printf. Printf, open the bracket, I'll place my open quotes and then I say enter the total number of variables. Now you need to make sure that there is an open quote and there is a close quote. So here I'm going to tap in so that it should be, no, there's no need. I'm going to tap and I tap so that it should be centralized. And now the next thing is that I'm asking here with this question, I'm asking the user to enter the total number of terms, of his variable, total number of variables. So now, total number of terms of variables, I'm going to take now the answer is going to enter and place it in the memory machine by using the function scanf. So when the person or the user is going to enter the value, I'm going to use scanf in order to take the value from the screen. So I'm going to use scanf, place the number in an integer type, and then place in the address of a variable I need to declare. So in order for you to place a number in a variable, you need first to declare the variable. So I'll come here and I will declare the variable I want the number to be stored in. So I come here, I say int, I declare it a variable type, data type of integer, n equals to, and I initialize it to 0. It's always good to initialize your variables. So I initialize to 0, and when it comes here, it will then have, when you enter the value, it will take the value that the user is entering. So you have this. Now after entering the values, I will say again to the user, printf, I come here, then I say, I go to another line, I tab it, or yes, I can go 2 lines down, I tab it, I say enter the variables you wish to calculate the mean. So enter the variable you wish to calculate the mean. Voila. This is what you have. Now you then go, you place semicolon at the end here, and make sure that you have again another printf. I have again another printf here. Now when I have this printf, I then come and then I go to another line, then I tab it. Here is tapped twice, so I'll tap twice so that the bill should be on the same line. I'll tap again here. So here I'll write variables. These are variables which are going to be entered. So 2 dots. So variables here. So here I can remove this semicolon. So here I have variables. Now print is printf. Now you have this variable go semicolon. Now here I'm supposed now to store the value that the user is going to enter into the machine. So in order to store, I'm going to use again a loop. I'm going to make sure that I use a loop in order to store it, because it can be even 100 terms. I don't want to store one by one though, so I need a loop to do it for me. So in order for me to use a loop, it's always necessary to first use a counter, initialize a counter, because with a loop you are going to do multiple number of actions. So you need a counter which is going to count those actions in order for it to go out of the loop. So I'll initialize the counter here. I'll say int I equals to 0. So I have int I equals to 0. I come here, I say I is less than n. Then I do this, I open. See that I equals 0. In this case, when the user is going to enter, so that the value will be 1, 2, 3, 4, 5, 6, 7, 8. He's going to enter 8 here. So since he's going to enter 8, you see that 0 is less than 8, so he's going to enter the loop. So inside the loop, I now want to assign the different values that are going to enter in an array. So I want to assign a different value which are going to enter in an array. So the first thing is that I'm going to create an array of size, the total number of terms that the man has entered. So that's the use of the total number of terms he's entering. Total number of terms he's entering is to make sure that the array size is compatible with it. So I'll come here now and initialize an array of floating type. So because the value which can be entered can be of a continuous series, continuous variables like 12.1, 12.2. So I'll place as floating types. So the name will be variable, and then the size will be n, the n number of terms that I initially asked you. Now you come here down. The next thing to do is while I less than n. While I less than n, now you are going to assign the different value that the man is going to enter into each of the corresponding location of the arrays. You first assign to a location 0. The first term in the array will be variable 0. The second term of the array is variable 1. Third term variable 2. The fourth term, and the last term is variable n-1. So variable 8. So what happened is that I will use my scanf, and then inside the scanf I now say that I initially stored in an integer, but I'm going to store now into a floating point, because the variable data type of variable array is floating type. So I'm going to store it here. going to be %d. When I come out, then I'm going to store in the address of variable, then I place it I. Now what happened is that when I0 is entering, 0 is less than 8, it's going to enter. Now it's going to store the first value in variable I in the first term of variable, of the array variable. Yeah. So when it's stored in its first term, what the next thing to do now is to do I equals to I plus 1 to make sure that when it goes down, it adds up. So the new value of I will now be 1. So 1 enters, it stores the second value, then 2 enters, it stores the third value, 3, and all that. Now go down. After having stored the values, the most difficult part will be attained. You need to calculate the mean. And to calculate the mean, the first thing to do when you want to calculate the mean is to order the series, because we said we need to calculate the median instead. And the first thing to calculate the median is to order the series, because we said the median is the middle value of variables in ordered series. You need first to order this in ascending order and then take the middle value. So this step will order the variables. So it's going to order the variables. So how will you do to order the variables? In order to order the variables, we are going to use this counter I. So we are going to use multiple counters. The first counter we are going to use will be I. This I will serve as a reference point. So this counter I will serve as a reference point. So the next thing we have int I int j equals to 0. So we also have another counter. Another counter will serve as the comparison. All this counter, the explanation is given in the previous tutorial when we were dealing with the calculation of the mode, when we wanted to count the different numbers. Now we have this will be used in the comparison of the reference point. This is a comparison of the reference point. Now, so you come down here, we have order of variables. The first thing to start with is when you want to use the int I, you must make sure that because I which comes down here will be of value 8. Now when it comes down here, you have to make sure that you initialize again back I to 0 for you to start and for you to enter the loop you will create here. So I'll create another loop, I less than n. When I create this loop I less than n, I enter into it. When I enter into it now, I create another loop y into I create j is less than n. When I create this loop, I enter into it, and then I will compare with the if statement. I say now if. So I want to enter because when I equals to 0 and j equals to 0, I will try to compare if the first element I equals to 0 is less than or greater than the one I want to compare with. So I'm going to use variable into I. So we are going to say variable j place is variable j less than variable I. Is variable j less than variable I? If it's less than, then you assign the value of variable j to variable I. as such. So you have this statement. So you say if what happened is that while I first is 0, it enters. Since it enters, come here and find j. So j is equals to 0 at this time because of this point. So j is 0, it enters less than n. What happened is that the variable j, so this is variable j. We know that variable j here. No, first this one is variable j. Variable j is the comparison and variable I is the main one. So what happened is that in this case, the first statement we say 12 is 12 less than 12. No, so the variable I, which is 0, is going to be maintained. Now when the if statement is done, what happened is that I want to continue counting and going in front. So if I want to continue counting and going in front, I need to say j is equals to j plus 1. So now what happened is that here I is equals to 0. Since I is equals to 0, it first does with 0 and compares. So here the first value will remain 12. Now because I want to place it in order series, I want that the value which is when the value 8 here is smaller than 12, 8 will take the position of 12. So that's what I'm trying to do. So if 8 here is smaller than 12, 8 will take the position of 12 here. This code we initially had, the code is going to result to some errors because upon saying 8 is going to enter, because variable j, when variable j is entering, it is going to enter all through the different part of the array. So there should be a little modification on this portion. Now we need to know again, in order for us to classify, to order this series, the first thing for us to do is to maintain this 12 at this position. Then you have to visualize the next number. The next number is 13. Compare the 13 with 12. If the 13 now is less than 12, then we are going to swap the position. So that's how to visualize it. Compare with the next number, then take this one, compare. After it has been swapped, we compare again the number with the next one, and or if it's smaller, we swap it. If then after it we compare again, then we swap it. After it we compare again. If it's smaller, then we swap it, and all that. When we do that, you have to make sure that when the first term 8, because the initial code was not considering that 8, when 8 enters here, it will not be considered. So what happened with the initial code is that it does not block the first space. So with the new code I'm going to write is that, do you know that the first element here will be 8? So I will make sure that this part here should be blocked, and it should not, the loop should not visualize again this part, and it visualize the next part. So how will I do this? So come down here. You know that at first when you want to compare, you don't compare with itself, you must compare with the other one. So that's how you visualize. When you want to compare the first value, you compare the first value with the next value. So that's why when you want to, the number of comparison, the total number of comparison are going to change from these are 8 elements. They are going to change from 8 times to 7 times. So I'm going to compare 1 time, compare 2 times with 8, compare 3 times, compare 4 times, compare 5 times, compare 6 times, compare 7 times. That's why I'm going to place here an n minus 1. So n minus 1 here. So now when you compare n minus with n minus 1 here, what happened is that the next portion of your code is going to contain j less than, going to contain j less than n minus 1 minus I. So we are going to have it at the next portion of your code. So this line is going to make sure that when you arrive at this point, when you have already compared for all the elements and place the value at this point, it does not go back again and do the comparison with the first value. What happens is that when you first place the value of 8 here, if you still compare the less than with 8, you realize that 8 will still be smaller than the next value which will come. So all of them, all of the range will be placing 8, 8, 8, 8, 8. That's why the initial code I did place 8, 8, 8 all through. So you have to change the code and make sure that when you place 8 here, 8 should not be compared again. That's why I come and I place a minus I here. So the minus I make sure that the position of the I counter should not be considered again, and we consider the next position, which are 4th. So the next thing to do in our code is to compare the j terms. So we are going to say if variable j is, so if variable, we can say if variable, we place here, we say j plus 1, the preceding term is less than variable, the initial term, variable j. Then what do? You enter into this, you make sure that it swaps. Now what happens here is that you ask the compiler the question that if 12 is if 13 is less than 12, then you are going to swap it. But in this case it doesn't happen, and you're going to come and find if 8 is less than 12. If 8 is less than 12, it's going to swap. So how are you going to write the code for swapping? To write the code for swapping, it is first go to initialize a number called swap, a variable called swap. We initialize the variable swap and we initialize it, we assign and initialize it to 0. So in swap equals to 0, or we can initialize it right up there. So we are going to instead going to initialize the value of swap as a floating type, because swap is going to contain variable, and variable can be floating, was initially initialized as a floating number. So we have swap here, we declare swap. So when we declare swap, we then we say that we are going to change the location of the two numbers. To change the location of the two numbers, we are going to place swap equals to, so what I want is that I want to place the value of 12 here, and I want to take the value of 8 into this position. So I'm going to say this will be equals to this, and this will enter there. So the first thing is that I'll contain the value of this one. So I do swap is equals to variable, swap is equals to variable j. So the first thing is that I try to contain it. When I contain our variable j in swap, I then take variable j is equals to variable j plus 1. Which is the next value. So it's going to contain it. When it now contain it, then I come back again, I say variable j, which was contained in swap, returns back to initial value. So now the next value, which is variable j plus 1, because variable j here has a value of variable j plus 1. Now we want to take the value of variable j now plus 1, variable j now, and place it back into this variable after swapping. So we take the value of swap here as such. So this loop is used for swapping. So after that, I come out of the if statement. And then
I'm going to add, because what will happen is that you have I equals to 0. You compare I equals to 0 for this number of times is 7 times. You're going to compare it 7 times. So I is less than 7. It's going to enter. So j, you have 0 now, is going to be less than n minus 1. 7 minus 1, it's 8 minus 1 is 7, minus 0 is going to 7 times. So I'm going to, what I'm telling my compiler is to swap for 7 times. This first times is going to swap with the first term is going to swap for 7 times. That's what will happen with this code. So now after swapping for 7 times, so what happened is that first when you want to increase, because it first start with the swapping with 13. When you visualize that 13 is greater than 12 by using this if statement, it's going to come out of if statement and then it's going to add up. So j is equals to j plus 1 year is going to be added. I remove this big j. J is equals to j plus 1 year. It's going to add it, go up, then go to a next term 8. So what happens is going to go to next term 8. 8 is now less than, then it's going to swap it. So 8 will be in this position, and then the next term here, because go to the next term.
This is the end product of our program. So we realize that when you I've modified the program such that here, in order to do the order of the variables, we have I equals to 0, printf. I have the ordered series here. After having the ordered series, I make sure that the y, I said that I say yi is less than n minus 1. I say less than n minus 1 because I realize that if I don't use that, when I use n minus 1, I make sure that the first term is comparing with respect to the second one. So I'm trying to compare this first term 12 with the second term 13, and when I compare it, I try to compare it with this next one. So I will do from here to here. When I do from here to this point, I say the first time, second time, third time, fourth time, fifth time, sixth time, seventh time.